So, welcome back. I am Amit, the senior maths faculty at the Nandyal Public School. So, as per I remember, till last class, I hope we are meeting after a long time, but I hope in last class I gave you the idea of the sets. What is the meaning of the set, and how can we represent the set? These two things is almost, I think, clear. We discussed that if the set is just a well-defined collection of the objects. It's something I will take a collection, but I will not say all collection is set. But if my collection is well defined, I hope you know what's the meaning of well defined. But if the collection is well defined, if you know what is coming in this collection, what is not coming in the collection, if I will give you an element and I will ask, will it come in my collection or not? And if you are sure that whether it's going to become or not, that type of well-defined collection you are calling it is a set. That's what we discussed till now. And maybe in lecture number 2, I gave you the idea that how you can represent such type of well-defined collection. Now I am coming on. Let's come on the screen, and I will start this lecture again by asking some questions. So let's come. Let me come on my screen now. Okay. So tell me the collection of all states of India. Is it a well-defined collection? Can you say that this is a set? Yes, you can say, because you know there are 26 states. It's a well-defined collection. I'm not saying it's. I can say it's a finite set. Finite set. Okay, and I never introduced this word, but okay. Now let me tell you. Let me introduce this word now. It's a well-defined collection because you know that what's coming in this collection and what's not coming in collection. If I will ask, let's say the Rajasthan. Is the Rajasthan is a part of my this collection? Obviously, yes, because you know the Rajasthan is one of the state of India. If I will ask, let's say the Karnataka, well, Karnataka will come in this collection. Yeah, it will come. You know, okay, let me ask, let's say China. Will China come in this collection? Obviously, no. So you know that what's coming in my collection and what's not coming in my collection. Then I can say it's a well-defined collection, or in a mathematics language, I can say it's a set. That's something I discussed in the previous class. Okay, I want to say it's not only a well-defined collection, but it's a finite collection. What's the meaning of this word finite? Let me complete this. It's something the finite. The finite means obviously it's a well-defined collection, but the elements which are coming in this set are, I can say, somewhere countable. You can tell that how many elements are coming here. When you have a collection of such type where you can count the number of elements and you can tell me in fact the counting, then I have just a specific name for that type of collection is a finite set. But I can say the number of elements which are coming in this collection is 26. So I can say the number of elements coming in this collection or coming in this set is 26. Because I can tell you that how many elements are coming here, I will say it's a finite set. I hope it's just a word, it's just a terminology. That's some specific type of set. I'm calling it as a finite set. Something. I hope it's not much hard to memorize this word. Finite means there's some specific number, and here the number is fixed. You know, 26 elements are coming in this collection, so I can call it's a finite set, right? Okay. Now let me ask again a question. Now tell me, is this is a set? The collection of all states of India starts from letter G. Tell whether this will call as a well-defined collection or not. What's your answer? The collection of all states of India, not all states actually, the states which in an English word which starts from letter D. So will you call it? It's a well-defined collection. Let me come on my map. Again, can you tell me which of the collections, which of the states here whose names starts from letter D? Oh, it's my one of my native state, obviously. Delhi is one of it. Do you know any other? I am very bad in social, but I think only Delhi. What do you say? Can I say only Delhi? Yeah, I think only Delhi. That's why. How many elements coming in this set? Only one, right? If I will say this is my set A, then I can say it's a set which contain only one element, and I can say that the element is Delhi. Am I right? Can I say this? I hope I can say this. Okay, actually, I have one specific name for this set also. These are just the names. You can just listen it and just keep this thing in your mind. How many elements coming in this set? Only one. Am I right? So, just for a namesake, the peoples are saying the set which contains only one element. They are calling it by a singleton set. The set which contains only one element, only single element, it's called a singleton set. Not much hard, right? So it's a singleton set. Yeah. Okay. But my question is, what's the relationship you can find in my previous collection, the collection of all states of India, and in this collection, the collection of all states of India, which starts from letter D? What's the connection in between them? Can you see any connection in between them? Yes. Just pause here and check. The collection of all states of India contain 26 letters, contain 26 elements, a little bit big set. But when I'm talking about states of India, let's start from letter A. It's contain only one element. But can I say it's contain only one element? But can I say, just I'm saying this and tell me, can I say this or not? But that element Delhi, that's also coming from my big set, from my previous set. My previous set contained 26 elements. It contains Jammu Kashmir, it contains Himachal Pradesh, it contains Punjab, it contains Rajasthan, it contains Uttar Pradesh, and so and so. There are 26 different elements here. And my next collection, which contains only one element, but that element is already present in my previous set, Delhi. Yeah. Or if you allow me, can I say this set, which I mentioned by set A, the singleton set, can I say this set is smaller set? I will give more example. But can I say this set is smaller set than previous set? Which set is larger? Obviously, the set of 26 element is larger. Obviously, the previous set is larger. But can I say that this singleton set lies inside my previous set? It's something maybe confusing, but can I say that I have a set of 26 elements? Let's say this is a circle which contains 26 elements here, and this set is just a small set inside a big set. Yeah. Okay, just hold a second. Let me come on my next example. My next collection is the collection of all English alphabet. What you will see, is it a well defined collection? Yes, it is. It's a collection of 26, maybe. I don't know English, maybe 26, 27. I don't know how many English alphabet. But yeah, it's a well defined collection. And the number of elements in this collection may be 26. A, B, C, and so to Z. The 26 English alphabets. It's a well defined collection. Right? Now can I ask some more sets? I'm mentioning, like my set A is the collection of, let's say, only three elements A, B, and C. Or maybe I can say the collection of first three English alphabets. In order, first three English alphabet. Will you say it's a set? Yes, it is. It's a well defined. But my question is again same. What can you say about this set and about the previous set? What you can say about this? My previous set is contained total 26 elements A, B, C to so and so to Z, and my this set A, contain only 3 elements A, B, C. What's the relationship between them? Can I say my this set A contained in my big set, this set A contained in the set of all English alphabets? Yes, I can say. I can say my set A contained inside the big set or inside the set of all English alphabet. Yeah. Or I have a one more specific name for this situation, and now I am going to introduce that word, and that is the motive to this lecture. Or I can say, if I will say that, let's say the maybe I can use the letter B. B is the collection of all English alphabets. Collection of all English alphabets. Then can I say my set A contain inside the set B? Can I say this? Or my new word which I want to introduce here is I can say my set A, the collection of only first 3 alphabet, is, please capture this word, is subset of set B. That is the word which I want to introduce here. The A is a subset of B. The subset means A is a smaller set and A is a set which contained inside B. That's the meaning of subset. I hope you understood. Or if I will go in my above example of states, then can I say this singleton set A is subset of what? Subset of all set of all states of India. Yes, I hope you are understanding what is the meaning of subset. When you are calling a set, this is the word. When you will calling a set is a subset of another set, that it means that that set is a smaller set and it's contained in the bigger set. That's the meaning. If I will say A is the subset of B, it means that all the elements of A, all the elements of A is coming where? It means A is somewhere lies inside B. A is subset, A is a set which I took out or which I created by using the elements of big set, or A is a set somewhere which is smaller set than the bigger set. I can say all the elements of set A is already coming in set B. Then I will say A is the subset of B. That's the meaning of saying A is the subset of B. Hold a second, I will give you the examples, but I hope you understood what's the meaning of subset. Let me come on my example. Okay, see the example number 1. Here you can see that I have 2 sets. My first set contains how many elements? 3 elements. The set A contains 3 elements. I can say 2, 3 and 5, or I can say it's the first 3 prime numbers. My set B contain more element than set A. It contains 5 elements, 2, 3, 5, 7, 9. Or I can say it contains first 5 prime numbers. Can you compare both sets now? And can you tell me, according to subset language, can you tell me which set is a subset of what? Obviously, you can say that A contains 2, B also contains 2. Okay, can I say 2 comes inside A? I hope you know the meaning of this symbol. This symbol means just 2 comes inside A, 2 belongs to A. And then you can say 2 belongs to B also. Then you can say 3 comes in A, and you can say 3 comes in B also. Then you can see 5, it comes in A, and then you are seeing 5 comes in B also. Are you seeing that the set A is a set which contain inside the set B, or can I say, if you allow me now, what can I say now in terms of subset language? Yes, A is subset of B. That's the meaning. A is subset of B. What do you say? I hope you understood. Okay, that is the thing which I want to clear it in today's lecture. What's the meaning of saying subset? When you will say one set is a subset of another. Oh yeah, there is one symbol I want to represent. When you are saying a subset of B, even instead of writing an entire words, you can say, you can use symbols, and you can say the set A subset of B. You can use this symbol. It's like somewhat like a C, not a complete like a C. It's something this symbol, and you can say A subset of B. It will read as A subset of B. This is just a symbol which calling it A is a subset of B. You will open the mouth toward the big set side, toward the big set side, and A is the subset, B is okay. Yeah, that is the meaning. A is the subset of B, and you will use this symbol for representing the subset. Am I right? Okay. Can I give you more examples if you allow me? So come on, example number two. Again, you can see two set here. The first set contain only two elements, or I can say first two natural numbers, and set B contain three elements, 2, 3, 5. Can you tell me any relationship in between them? A contain two elements, 1 and 2. B contain three elements, 2, 3, 5. Can you tell me anything? Obviously, A is the set which is smaller than B, but I cannot directly say if it is smaller, it would be subset. No, I cannot say this. I need to check it out whether all elements of A comes in B or not. So here you can say 1 is coming in A, but can you see 1 in B? No, 1 is, if it is not coming in B, you can just cross it and you can say 1 is not coming in B. So what's the meaning? Can I say they are subset? No. So I can say that A is not subset of B. That's the meaning. Or if you want to use the symbol, which I am going to use in upcoming classes, you can say that A is, it's a symbol of subset, but it's not a subset. Just cross it and you can say A is not subset of B. That's all. I hope it's much easy to say that when it would be a subset and when it will not be a subset. Is it? If you allow me, can I give you more examples? Okay, so here there are 6 examples and I will do all one by one. You just need to tell me which is subset and which is not a subset. Let me come on first question first. How many element A lies? A has 4 elements, I can say 0, 1, 2, 3, and B has 5 elements, 1, 2, 3, 4, 5. I can say that A is somewhere smaller than B, but I need to check it out whether all elements of A coming in B or not. So you can see 0 is the first element which comes in A, but if 0 comes in B, no, 0 is not comes in B. I'm just cutting that. It's not comes in B. So what's the meaning? It means that A is, can I say is a subset? No. I need to say A is subset, cross it, A is not subset of B. That's the first. I hope it's much easier. Can I come on second one? Okay. My second question, if I will see here, A is, oh yeah, just I want to introduce this word where it's mentioned here. Okay. Just may hold me second. Yeah, they are using this symbol. The set A is this one. Let me introduce what it is. After this, I will give a just a short video on the symbol, but it means it's an empty set. Just after this, I will give you a short video on this. What's the meaning of empty set? Let me just tell you in brief for here. This symbol, which is pronounced as 5, it means that this is the set which doesn't contain anything. It's like a box which doesn't have anything. That is also a set which I can say empty set. It doesn't have anything. It's just like a completely void set, completely null set, right? It's an empty set. It doesn't have anything. How many elements coming here? It's a zero. You can say it's a set which contain no elements, or I can say the number of element coming in this set is zero. In this set is zero, right? That type of set I'm generally representing by this symbol, the 0 and 5. I'm going to generally representing by this symbol, and that's called empty set. If just before going, if you want example, I can give. For example, I can say the collection of I can say E1 natural number not divisible by 2. Not divisible by 2. Can you tell me if this is a how many elements will lie in this set? The collection of even natural number, 2, 4, 6, 8, and so, but not divisible by 2. Can you tell me how many elements will come here? Can you tell me any even natural number which will not divisible by 2? No, all the even natural number divisible by 2. So what's it? I cannot say it's not a set. It's a set. But it's a set which doesn't have any element at all, or I can say it's an empty set. So I hope we will see so many examples. Just wait for the next video. I will give you the meaning of empty set, but that's called the empty set. Am I right? Okay. So I hope it's clear. Now let me come on my question. If they are saying A is the 5, or I can say A is the empty set, and what's the B? They are saying B is the set which contain only one element, that is 0. Now tell, which set is smaller? A set is smaller because A is the set which doesn't contain anything, and B is the set which contain one element, which is 0. Can I say, what can I say? Or can I say they are subsets? What's the meaning of subset? It means that pick up any element from the set, and if you can find that element in another set also, then you can say they are subsets. Will you pick up any element from my first set? Is there any element in first set? No, this is completely empty set. You cannot pick up anything from there. So if there is nothing there, then can I say something very confusing statement? But if there is nothing there, if there is no element there, then can I say I can pick up anything from that set and it will automatically be in the my set B? Because it doesn't have anything. So can I say all elements of A, it doesn't have anything, but can I say that all elements of A contained in B? Because if A doesn't have anything, that means you can pick up anything from A and it will automatically be present in my set B. So I can say that A would be subset of B. It's always true. The empty set is always subset of all. Is always subset. Is always subset of all set. Because if the set is empty, means it doesn't have anything, and if it doesn't have anything, then you can pick up anything and you can find anywhere. So it's something I can say improper result, a trivial result, but I can say this is always subset of everything. Empty set is always subset, and here also I can say A is subset of B. Am I right? Okay. Now let me come on my third part. In my third part, they are saying A is the collection of 3 elements, 1, 2, and 3, and B is the collection of again 3 elements, 1, 2, 4. Can you say they are subsets of each other? Both contain same element. So let me check. The set A, 1 is coming in set A. Can you find 1 in B also? Yes, 1 coming in B also. 2 is coming in the first set. Can you find 2 in the second set? Yes, 2 is present in the second set also. You can find 3 in the first set. Can you find 3 in the second set? 3 is not coming in first set. So I can say A is not a subset of B. Am I right? Third one is where you can say A is not subset of B. Let me come on fourth one. I need a different sheet for fourth one. Okay, let me come on fourth one. The fourth one, read the first one. It's a collection. Oh, it's something, a set builder. We will come later on this one. But read it. It's a collection of all integers. And what type of integer? The integers whose square is 1. So can you tell me the integers such that whose square is 1? The number whose square is 1. I hope you know. The 1 is the first number, the 1 square, 1 times of 1 is 1, and another is minus 1. It's also an integer, and minus 1 square, minus 1 times of minus 1 is 1. Okay, so this is my first set. And what's my second set? The set B is the collection of natural number whose square is 1. So set B is again same thing, but here all negative numbers are not allowed. Only positive numbers are allowed, so that square is 1. So what the B will contain? Only one element, 1. What can you say? How many elements A contain? 2. And how many elements B contain? 1. So obviously there is no possibility for saying that A could be subset of B. A has bigger set. Let me check in a reverse order. Can I say B is subset of A? B contain one element, and that one I can find here also. So what can I say? I can say B is subset of A here. Am I right? That's the mean. B is subset of A. Yes. So I can say B is subset of A. That's the meaning. Am I right? Oh yeah, actually there is a one more way to saying the same statement. I hope it's clear. B is subset of A. But in one more way, I can say the same thing. If you don't want to use this word subset, there is a one more word. You are saying B is subset of A. But if you want to change the order, I cannot use a subset word then. If I will change the order, I can say B is subset of A. That is correct. But if I want to change the order, I can say A is what? Not subset. Now I cannot use the subset word because A is not subset of B. But the word is A is superset of B. Superset of B. That is also a correct way of saying this. If you are changing the order, either say B is subset of A, or if you are really want to say in reverse statement, so you can say A is bigger set or A is superset of B. This is the second way of saying this. These are just names which you need to keep in your mind. I hope you can do this, but that is the meaning. Either say B is subset of A or either say A is superset of A. Can I come on my next example? The fourth one done, first, second, third, fourth done. Let's come on fifth one. Okay, let me insert a new page. Okay, now the fifth one is the set A, which is the collection of even natural numbers. What is my first set? The first set is collection of even natural number means. I hope everybody knows the even natural numbers, even positive numbers, 2, 4, 6, 8, and so and so. Right? And let's block, close them in curly bracket, right? Now, what is my set B? The set B is the collection of integers. What's integers? Very big set. I can say all negative numbers, including 0, and all positive numbers. Can you tell me which set is bigger? Which set contain in another set? Yeah, you can say that. Here you can say all positive even numbers, and here are all numbers, positive, negative, and everything. So obviously my A set will completely contain inside the set B. Am I right? I can say A is subset. Yes, because here all even natural number will come, right? And so and so. Or really, if you want to say in reverse order, what can you say? If you want to say B is what? What word I can use here? I cannot use subset. Superset. So I can say B is superset of A. That is a correct word which I can use. Am I right? Okay. Let's come on my last example and then we will over it. The sixth one. The sixth one. Let's come on my set A. The set A is all integers. Let me again come on all integers. Okay. Just give me a second. Mm, okay. Okay, let me do there only. Just let me come up. That's what is my set A? The collection of all integers. So what A set lies? The set A lies all integer. I think this is only my set A, which contains all integer, all negative numbers, all positive number, including C. Right? Okay. Now what my set B? The set B is all rational numbers. Set B contain all rational numbers, right? We can remove this. Okay, this one also. Okay. The set A is the collection of all integers. I hope Z is the symbol. And set B is collection of all rational numbers. What can you say? Yeah, obviously, I hope you know. Integers are only the numerators, the numbers, and rational numbers are the fractions where something comes up, something comes down. And if you will keep the down number fixed as 1, then all integers are already coming there. Am I right? So can I say all integers are coming inside rational number, or can I say all in the set of all integers is subset of rational number? Yeah, I hope this you know. And even that's all. Oh, even I can continue this. The set of rational numbers, which is something only the fractions. And I hope there are some number which cannot be write down in fraction, and if I will add them in the collection of rational numbers, I can say all real numbers. I can say my all rational numbers is collection of set of all real numbers. Am I right? Okay. I think this just like a chain. Oh, even I can continue. Can I ask this question? It would be confusing for you, but let me ask. Can you tell me a set where set of integer act like a superset? Don't confuse by this word superset. I just want to fill a number here so that I want to fill up this space so that it will become a subset. It will become a subset of set of integer. But in reverse order, I want to fill a space here so which in such a way such that set of integer act as a superset. What can I fill here? It's all I can say all positive number, negative number, including zero. Can I fill up whole numbers here? All positive whole numbers, then obviously the set of whole number will is a subset of set of integer. Can you fill any more thing here? Can I fill set of natural number here? Yeah, it's natural number is subset of whole number because only zero is missing in natural number. It's coming more. And even you can create a chain. and even I can fill two times of natural number here, all even numbers, and this is just like a chain you can make here, which is a chain of subsets where everyone lies inside of another, right? Okay, that's all. Is it understandable? Is it understandable that when you say the one set is a subset of another, or in other language you can say when the one set would be superset of another? I hope it's much easy and you understood this. Okay, yeah. Now, if you allow me, can I give you more subsets? Yeah. So now, if you allow me, I want to give you the subsets. There are so many subsets. Okay, now my next question is I want to count all the subsets. How many subsets you can write? That is my next piece of lecture. My one piece of lecture is complete where I discuss about what is the meaning of subsets. Now, will you help me to write down all the subsets of a set? Let me tell you what's the meaning. Okay, so how can I erase this? Just give me a second. Let me try to erase all. Stock eraser. Okay, stock eraser. Okay, so now let me come here. Okay, now that's it. Now I am giving you a set. Let's say my set A contain only, let's say, one element. Let's contain only one element, one. Can you tell me how many subsets you can create for this set? I hope you know now what's the meaning of subset. Now I want to create the subsets of it. And can you tell me how many subsets I can create? Yes. What is the first subset you can create? This set contains only one element. And if you want to create a subset, what's the meaning? You want to create a set which would be, I will, which would be smaller. Somewhere I can say which would be smaller than this set. If this set contain one element, if I want to create a subset, how many elements should be there? Less than one. What's less than one? Zero. So do you know any set which contains zero element? Yeah, I introduced the empty set. Can I use this symbol now? This empty set is one of the set which would be subset of my set. And I even said it's subset always. Okay. Do you know? Okay, I think only one set is there which contains zero element, which is empty set. Now come on. Can you tell me any other subset? Actually, one more is possible. The set itself. The set itself. Because set A contain one element, I will bring up the same set again, and it's also a subset. Because if you will choose any element from this set, it is already present there. Even they are equal, they are same. So these two are always present everywhere, but I can say these two are the subsets of this set A, right? So how many subsets you can make here? Two, phi, empty set, and A. Yes, is it okay? Okay. Now let me give you another example. Let me give you one more example. Let's say now I have a set B which contain, let's say, not one, let's contain two elements, 1 and 2. Now, can you tell me, can you list all the subsets, all the subsets of my set B? Can you list up it? Yes. Okay, how many elements present in my set B? Two. There are two elements present in my set B. So, if I want to create a subset, how many elements should be there? Less than. Maybe two, but properly less than. Means it could be zero element, it could be one element, and it could be two element. Let me come on first case when it has only one element. It could be zero element. So do you know any name of a subset which contains zero element? Only one subset, the empty set. That is the first set, which I can say it's a subset of my set B is the empty set. Am I right? Which contain only zero element. Okay. Now let's come on. My original set contained two elements. So the sets which contain only one element could also be a subset of it. So can you create the subsets which contain only one element? There are so many ways to write down set which contain one element, but I want to write down subsets of it. So I want to write down the set which contain only one element, but that element I need to choose from here. Then only it will become subset. So can I say this is a subset? Yeah, it's a collection of only one element one, which comes from here. So I can say one, this is whatever, it's a subset of B. Is there any other way of write down a singleton set, which would be subset of B set? I filled one here. Can I fill two also? Yes, I can fill two also. I can say this will also be subset of B. One element comes from set B. What do you say? Is there any other way to write to create the singleton set? Create the singleton set which contains one element? No, because the set was has only two elements, one and two, and I create the singleton sets. So let me complete two now. Now let me come. Can you create subset which can contain two elements? Yeah, the set itself. I can say this one. Oh yeah, I can use this equal word here because this is a subset as well as equal. Now this. Okay, so these four. Can you create any other subset of it? I create the subset which contains zero element. I create the subset which contains one element. I create the subset which contains two elements. Is there any other possible ways? No. So how many subsets you can create for this set? Four. And you can see all the four subsets here. What do you say? Am I right? If you allow me, can I give you one more example? Yes, I want to give. Just hold a second. I will give you one more example. Now I am choosing a set which contains three elements. Let's say 1, 2, and 3. Now you will understand better. And now I want to create all subsets of it. Start. My set contain three elements 1, 2, and 3, and I want to create the subsets of it. So means I want to create the sets which are smaller than this. That's only the thing question. So how many element I can fill, how many elements I can, how many sets I can take, or how many element possible in my set which would be smaller than this? It contains three elements. So I can take the subsets which contain zero element, which contain one element, which contain two element, or maybe set itself which contain all elements. Can I start with zero? Okay. So now let me write down my first set. There is only one set is possible which contains zero element is empty set. This is a subset of C. Now can I come on a set which contains one element? How many subsets are possible here of set C which contain one element? Maybe you can say this is my set 1, on the set which contain only one, that is a subset of C. Or maybe you can say instead of 1, I can take the set which contain 2, That will also subset of C. Or maybe I can say the set which contains 3, that will also be a subset of C. What do you say? 3 subsets are possible which contains only one element, and it would be subset of C. Is there any other possibility for singleton set? No. I'm using this word singleton, but it just means one element. I hope it's clear. Okay, now let's come on fifth one. Now I will start to count the subset which contain 2 elements. Now be careful here. I want to fill up 2 elements here, but obviously I want to choose 2 elements from my parent set, from my given set. So what 2 elements I can take here? Obviously I can take first 2 elements, 1 and 2, and I can say this is my subset of my set C. Is there any other way to choose these 2 elements other than 1 and 2? Don't say 2 and 1, because maybe in first lecture you saw that order doesn't matter in set. Don't take 2 and 1. 1 and 3, yes. 1 and 3 I can take, and I can say it will also be a subset. Is any other way? I choose 1 and 2. I choose 1 and 3. Is it any other way to create subset of 2 elements? 2 and 3, yeah. That is also a subset of C. Is there any other way? No, only 3 ways. 1, 2, 1, 3, and 2, 3. After that, nothing. Now, can I create the subset which contains 3 elements now? That is nothing but an improper set. The set itself, all 3 elements will come here, and I can say this is also a subset of it. What do you say? Am I right? So these are 8 subsets are possible. Now you cannot create anything. Am I right? So that's how you can list up all the subsets. Okay, but my point is to count them. My point is to literally count them, that how many subsets you created everywhere. Okay, here if you will see that when my parent set contain only one element, then how many subset you list here? If my parent set contain one element, then how many subsets you create? Then you create 2 subsets. Am I right? Okay. When my parent set contain 2 elements, 1 and 2, how many subsets you can create? 1, 2, 3, 4. You create 4 subsets. Am I right? Oh, yeah, if you will allow me, can I say this 4 as 2 square? Yeah, I can say this. Can I say this subset as 2 power 1? I want to come on result, that's why I'm doing this. But when the set A contain only one element, my subset is 2 power 1. When my set contain 2 elements, my total number of subsets in that case is 2 power 2. Let me see in last case. When my set contain 3 elements, how many subsets you create? 1, 2, 3, 4, 5, 6, 7, 8. 8. What can I say to this 8? 2 power 3. Yes. Are you seeing this? Now my next question, very trivial question. I hope you can guess it. What would be my next question? If my set A contain 4 elements, 1, 2, 3, and 4, can you tell me how many subsets you can create now? See, go back. When my set contain only one element, you said your total number of subsets is 2 power 1, 2. When my set contain 2 elements, you say total number of sets is 2 power 2. When the set contain 3 elements, you say total number of subset is 8, 2 power 3. Now tell me, when the set contain 4 elements, how many total number of subset would be there? 2 power 4, 16. If you have time, you can write down all 16. I'm not writing them, but there would be total 16. It would be your homework to write down all 16. And obviously, you can write down all 16. It's not much hard, but there would be total 16. It would be easy. Start with 0, empty set. Then start with the subset which contain one element. It's the set contain 1, set contain 2, set contain 3, set contain 4. Then come on the collection of so those which contain two elements. Take 1 2, take 2 3, take 3 4, take 1 3, take 1 4, take 2 3, take 2 4, take 3 4. And then count set of all elements. And total 16 you can list up. You can do this exercise actually. Just do this. I'm just giving you a homework here. Let's write down all 16 subsets. Right? That is your homework. But my question is, if the set contains 5 elements, how many subsets would be? 2 power 5. If the set contains 6 elements, let's say my set A contains 6 elements, how many subsets would be? 2 power 6. It would be 48 or somewhere. No one is asking to you list up all, but at least you are getting the count of it. Or what I want to say, if my set contain n elements, if my set contain let's say n element, then how many total number of subsets you can create? 2 power n. That's always, it's like a formula which you need to keep in your mind. Your set has total 7 elements, total subsets are 7. Your set has 1 lakh elements, total element is 1 lakh, and so on. That is a great formula. Yes? Okay. So that's all about the subset. I will come back again and I will. Okay, before ending, if you allow me, can I give you one more thing? Let's say I have set of all real numbers. Okay. Can you tell me how many elements are coming in real numbers? Infinite, right? So many. It's non-definite. So can you tell me how many subsets you can create here? According to my formula, 2 power infinite, right? Which is somewhere I can say right, somewhere I can say wrong. It's not a valid way to saying 2 power infinite. I can say this formula only working when the set is finite. When you know how many elements coming in this set, then you can tell how many subsets would be. This is a wrong way of saying this. Just I want to make sure. Don't say this. This is a formula working only in case of finite set. If the sets are infinite, I can say there will be infinite many subsets, but I cannot say 2 power infinite. Please just escape out from saying this statement. Okay. So I think the lecture is almost covered up. Tomorrow I will come on some, the good set, the good subsets of real number, which is called intervals, are just an interval in a big movie. I will cover up tomorrow. That's all for today. You will get a worksheet for today. Just cover up those worksheets and come back with the answer tomorrow. Goodbye. Have a nice day ahead.